So in question 3, we've got the results of measuring total daily rainfall in Leeming for 1987. Here are the results laid out. We've got the millimetres of rainfall measured and the frequency these occurred. Question A, explain how the dataset will have to be cleaned before Ben can start to calculate the statistics such as mean and standard deviation. Well, our problem is this value here. TR is trace. So there's been a trace of rainfall, and it would have to be less than 0.1 millimetres. So you've got to make a decision, really, of either saying, well, let's consider up to 0.1 millimetres, which is an incredibly small amount of rain that's been collected. We can consider that either as 0 or 0.05, let's say. I think the best thing to do is to treat the trace samples as 0, but that will gain you the 2 marks if you explain and write that down. Part B. Okay, so we've been told there are 184 of the values, and Ben estimates that the sum of the x values is 390 and the sum of the x squared values is 4336. So let's write that down. So first of all, part 1, we need to calculate the mean. Well, that's equal to the sum of all the values, so this is 390, divided by the number of samples, which is 184. And if you pop that into a calculator, you get an answer of 2.12. That's the first of the answers. Now for part 2, we need to find the standard deviation. Also in the formula sheets, we've got MOSM, which will give you the variance. And from that, we can find the standard deviation. And MOSM says that the mean of the squares, here are the squares, and we take the mean, minus the square of the mean, will give us the variance. So popping our values in, we get that V is equal to, as we've said, 4336, divided by 184, minus the answer to the mean, which is 2.12, which we square. And that I get as 19.0708. And it goes, and if we square root, we get an answer of 4.367. And that's the answer to the second part of that question. So part C, Ben is now suggesting we can use his results that we've used in part B and part A to estimate the annual mean rainfall in Leeming for 1987. We've got to use our knowledge of the large data set to give a reason why this would not be suitable. Well, we don't know, for example, what months these results cover. If they're in the winter, we will get presumably a higher rainfall content than we would in the summer. And if they were the summer, equally, we can't predict the winter. Again, you've just got to write that down as a sentence. And I've said that the 184 days that were sampled might be season-specific and therefore not suitable to extend for the whole year. The answer to part 2 is broadly similar to the answer to part 1. It depends when these results were taken. If they're summer results, then I'd expect that the mean rainfall to be a huge underestimate. If these are winter results, I would expect the mean total daily rainfall to be an overestimate. So it just depends what time of the year these were taken. So I've said here, if the results were covering the summer period, then the mean daily rainfall will be calculated low.